Sine,
cosine.
hold it, I gotta get the alpha and beta over here. And cosine of alpha plus beta is equal to. Now I'm ready, go ahead.
Sine, cosine, cosine, sine. Cosine, cosine, sine, sine.
Thank you. Alpha, beta, plus alpha, beta, alpha, beta, minus alpha, beta. Okay, so there are those two identities. They are probably the most important ones to memorize, and from those you can derive essentially everything else. In addition to those, you need to know odd and even. That is sine of minus alpha and cosine of minus alpha. And after that, you probably need a couple of the basic ones, like sine and cosine of pi over 2 and of pi. And from that, you should be able to derive all the rest of them except for two identities, which we will also do today. Now, these two identities, you can also get the negative ones, and let me write them down because I want to use them. Written these identities so many times in a long time, but we write them down all the time. All right, if you take a look at the right-hand side, you've got a sine alpha. These first and third ones, the two of them for sine of alpha plus beta and alpha minus beta, if I add them, sine of alpha plus beta plus sine of alpha minus beta equals. This piece and this piece are the same, so I write it down as two of them, right? 2 sine alpha cosine beta. And what do I do with this piece and that piece? They cancel. And so this is called the product to some identity written around the opposite order. If you have the product of two trig functions, sine and cosine, you can write it as the sum of two sines. Sine of the sum of alpha and beta and the sine of the difference. And sometimes you've got to divide by the half. But this is a product to sum formula. And it's usually written in that order. Product to sum formula. Likewise, if you take the second and fourth ones and add them, cosine alpha plus beta plus cosine of alpha minus beta, you get, let's see, adding these two add up, I get 2 cosine alpha cosine beta. Okay? So if you have the product of a sine and a cosine, you can figure it out. If you have a product of a cosine and a cosine, you can figure it out. Okay? Notice, oh yeah, these terms canceled. So that's the product of two cosines, one sine and one cosine. We are missing something. What happens if you have the product of two sines? How are we going to get that? When I use this identity and this identity, every time you had a sine times a cosine, a sine times a cosine, a sine times a cosine, a sine times a cosine. Okay? And so that can only give me sines times cosines. Yes? You take this one and that one, and you put a subtraction on this one. Okay? So then we do cosine of alpha plus beta minus cosine of alpha minus beta equals, right?
Actually, you do it the other way around. Yes. Cosine of alpha minus beta minus cosine of alpha.
Okay. Cosine of alpha minus beta minus cosine of alpha plus beta. He's saying take this one and subtract this one. When you do that, cosine alpha cosine beta minus cosine alpha cosine beta cancel. Then you get a sine alpha sine beta. Sine alpha sine beta. And minus a minus is a plus. Sine alpha sine beta. You get two of them. So there's how you get your third one. Okay? Now there's actually a fourth one in these identities. You can take these two and subtract them, but you really don't get anything new. Okay? If you take the first and the third and subtract them, these pieces cancel and those pieces add up, but it's still a sine times a cosine, so you don't have much new. At some point, I gave you a list of all the identities, this list, okay? And it was called Identity Summary. After review of trig, Identity Summary. So we have the ratio identities, reciprocals, the quadrant signs, the Pythagorean identities, negative angles, complementary, supplementary, sum of two angles, difference of two angles. That's these two and these two. Then we come to the double angle formulas, which we did last time, and I gave you a homework assignment to figure out the square formulas, which were next. I did one of them in class. The other one you were supposed to do at home. Okay? And then we have the half angle formulas. I'll skip for a moment. Then we have the product of sum formulas, which are these three, and a fourth one, which doesn't really give you anything new. And then we have the sum to product formulas. And I will do one of them right now. So we have equations 1, 2, and 3. Pick one of them. How many vote for number 1? How many vote for number 2? How many vote for number 3? Number 3 wins, because there were 3 votes. That only had 2 votes. Okay, so we start with this one, and we bring it all up here. Okay, and so we have cosine of alpha minus beta minus cosine of alpha plus beta equals 2 sine alpha sine beta. All right, I'm going to define alpha minus beta to be gamma, and I'm going to define delta to be alpha plus beta. Are any of you bothered by the fact that I'm using so many Greek letters?
Yeah.
I think it's bothered me just a little bit.
Yeah, I don't even know what they're called.
Alpha, beta, gamma, delta.
Yes.
Too many.
Alpha, beta, gamma, delta. The first 4 letters. So should I switch to Roman letters?
We do regular English letters.
That's Roman. Romans were the ones who invented our regular alphabet.
looks
That's not a nice one.
A, B, no, A minus B. Right. A minus B, B. A plus B. A and B. Is that what I have down here? With alphas become A's, betas become B's. This is C and this is D. C is A minus B and D is A plus B. Is that good? That make you feel better? I know the letters of the alphabet for no reason at all make people uneasy. Okay? But they mean the same thing. All right, so if I have this C and D, what is C plus D?
2A.
Hold on. 6
No.
Wait.
Come on, Mark.
Plus.
Give me an honest answer.
That cancels out.
Mark, what is it?
2A.
0.
It's not 0.
2A.
2A. You got an A minus
Oh,
B
yes.
plus A plus B.
It is 2A.
There are two A's there. Okay, and D minus C. What is D minus C?
Okay, hold on. Hold on. Okay, A plus B minus. Okay. It is 0. That.
You forgot you're distributing your minus sign. I'll do it slower. D is A plus B minus C, which is A minus B. You got to remember parentheses there. If you don't and just do minus A minus B, everything will cancel off. But this is minus A plus B.
So
So it's B plus B is 2B. Or not 2B. That was a
Wait,
literature reference. And
Wait.
only a small number of you got it.
I'm confused about this.
You're good at everything.
If I have minus the quantity 7 minus 3.
Okay.
7 minus 3 is,
4.
so this is minus 4, right?
Yeah.
On the other hand, minus 7 plus 3 is,
-4.
okay? So that minus sign hits here, and it hits here, and minus minus becomes a plus.
Okay, I think I get it. So
Okay?
this is
The negative of the negative is the positive. Okay?
It's the same as multiplying a -1 outside the parentheses.
Yes.
Okay. Because this is polynomial.
Okay, so this is C plus D, this is D minus C. So turning it around, A is C plus D over 2, B is D minus C over 2. And so this identity can be rewritten as cosine of something minus cosine of something equals 2 sine of something sine of something. Okay, so I want to rewrite everything in terms of C and D. What is A minus B?
C.
C is written right there. Okay? What is A plus B? And now what is A?
C plus D minus over 2.
C plus D over 2. What is B? D minus C over 2. And this is the sum to product formula. This is the product to sums. That is sums to products. And
Wait.
if you look on your sheet here, you see product to sum and sum to product. But the letters of the alphabet have been switched back again. Yes?
Would the 2 sign cancel out the divider?
No.
No.
No, multiplying, dividing by a number inside of the sign function is not the same as multiplying outside.
Okay.
Okay? If you look at the graph of the sign function, which looks like this, the 2 outside doubles the height. Stretches it vertically. The 2 or half inside, a half there stretches it out this direction.
Ah.
Okay?
Now.
And so those two things are not the same kind of operation, multiplying inside and multiplying outside. Okay? If I did a 2 inside, so there's the original one was sine. This one is 2 sine. This one is sine of A, sine of A, sine of 1/2 A. And if I go sine of 2A, it'll be twice as fast. Okay? And that would fast one is sine of 2a. And they're all different. Okay? You can't do stuff inside and outside of the function and expect them to do the same thing. Okay? The one outside stretches if it's bigger than 1, shrinks if it's less than 1. The one inside stretches if it's less than 1, shrinks if it's bigger than 1. Okay? Just like shifting, the one inside is intuitively backwards. Okay. All right. Now, is everybody here now? Did you finish the roll sheet?
You finished?
Oh, you were doing it.
Anastasia's not here, but.
Huh?
Anastasia's not here.
Okay. Who didn't get one of these yellow sheets?
Good one, yellow.
Yellow sheets. Yellow sheet. Okay. There was homework, which I said to do today.
We just said, does anybody? No.
Okay.
I said
Chill, Mark. I gave out a homework assignment, but I only said it verbally last time to redo the proof I did for cosine of alpha minus beta to do cosine of alpha plus beta. And 2 people have so far turned that in. Does anybody else have it down?
Oh, yeah.
Be sure your name's on there if you're going to turn it in. And then there was a second problem of starting with the double angle for cosine and getting the square formula for cosine. Okay. Anyone, did you do it?
I think
Not quite.
they're working on it.
Okay.
Don't you ask it?
Hmm?
Do you, are we doing like if you did one of them?
You can, yes. This is not school, so I'm not going to worry about it officially. If you really don't want to do it, you don't have to.
Is this a primary?
No, it probably because these are in the opposite order. And you flip the sign inside the sign, it becomes outside. Let me mention that in a second. Okay, so the yellow sheet is because I heard that some people did not know the statement of what problem I was asking. And so if you don't want to turn in today, you can turn it in next time. And so one of the sides which says homework for 618 or 620, the first problem is what I asked you to do on the sum of 2-angle cosine formula. And then the second one is for the cosine squared formula. So that's just what I asked you to do for today. If you didn't do it for today, you can give it to me next time. If you turn it over, there are now 2 problems. One says start with the double angle formula and derive the 2 half-angle formulas, which are on that sheet. They're up there on this page, okay? And the trick is to take the cosine of the double angle formula, replace alpha by 2 beta, or beta by half of alpha, and then just rearrange, and you come up with the square root formulas, okay, that give the half angles. So if you know 45 degrees, you can get 12.5 degrees, okay? I also asked an open-ended question last time. What is the smallest angle you can get the sines and cosines of? The smallest whole number of degrees. Has anybody thought about it? How do you get 15?
30 minus
45 minus 30.
45 minus 30, okay? How do you get 7.5?
Divide that by 2.
You divide 15 by 2. How do you get 22.5?
You multiply that times 3.
5 divided by 2.
45 divided by 2.
Yeah, you can do that.
What else is there? So we got 7.5 and 22.5. What's the difference between them? 15 again. That's not useful. I think I remember the other day figuring out a way to get a 5 degrees.
30
Divided by 3.
But I believe the smallest number of whole degrees you can get is 3 degrees. And I'm not sure I know offhand what adding and subtracting and dividing by 2 and adding back again eventually leads to 3 degrees. Yes.
Divide 15 by 5.
Do we know how to an angle trig identity for 1/5 of an angle?
What do you think about that?
Yes. We know how to double an angle and halve an angle, and we know how to add 2 angles. We can also do 5 times an angle. You want to see how you do 5 times an angle?
Sure. Why not?
I'll show you how to do 5 times an angle. I'll leave up those identities over there because they're important. Okay. Okay. Say cosine of 5 theta is cosine of theta plus 4 theta, which is cosine minus sine of theta and 4 theta. Now you need to figure out cosine of 4 theta and sine of 4 theta. So cosine of 4 theta is equal to, you can say it's theta plus 3 theta and use this identity, or you can say it's cosine of a double angle. Cosine, it is
That's a good
cosine of 2 times 2 theta, which is cosine squared of 2 theta minus sine squared of 2 theta. Okay? So that's the double angle formula with the angle being 2 theta. And now we need to know cosine of 2 theta and sine 2 theta. But we know those. So this is the square of cosine 2 theta. Cosine squared theta minus sine squared theta. Minus the square of sine of 2 theta, which is 2 sine theta cosine theta. So there I have cosine of 4 theta, all in terms of sine theta and cosine theta, and that cosine of 4 theta gets substituted in there. Now I need sine of 4 theta. Sine of 4 theta is a double angle, so it is sine of 2 thetas, which is, the double angle formula for sine is 2 sine of an angle cosine of an angle. So sine, the angle is 2 theta. And then I have the double angle formulas for them. 1 minus cosine squared. No, that's not that one. Cosine 2 theta. Sine, I'm doing it wrong. I'm doing 2. Sine 2 theta is 2 sine theta cosine theta. And then the cosine 2 theta is cosine squared theta minus sine squared theta. So, if I know sine theta and cosine theta, I can get sine of 4 theta and cosine of 4 theta. From those, I can get cosine of 5 theta. Okay? Likewise, you can build up cosine of n theta for any n. Okay? And there are standard formulas for all of them. But they all follow from these. Okay? If you know these 2, you can do them all, essentially. Okay, that brings us to the last 2 identities, which are not even on this sheet. Hold it. Yeah, no, then I have to
Parents, Windows, old Windows
those are the proofs. Next time I have to give you the proofs. Hand them out.
Really badly.
I can't give them to you quite yet because you're still doing homework. Okay. There are 2 more identities which are totally different from all the rest, and they need separate proof.
Oh,
So we will do that.
Weird.
One of them is called the law of sines, and the other is called law of cosine. And they have to do with triangles.
pretty good at these.
We have a triangle where the angles, no angle is a right angle, might be a right angle, but doesn't have to be. And we have three angles. Sorry, I'm going to call them alpha, beta, and gamma. The side opposite alpha has length A. The side opposite beta has length B. The side opposite gamma has length C. Okay? The law of sines says sine alpha over A equals sine sine beta over B equals sine gamma over C. That's the law of sines. And we really only need to prove one pair. We don't really need the third one because it's just a renaming of the three angles. Okay? And sines. Okay, the law of cosines. Says you pick any one side, say C, its square is equal to a squared plus b squared. That looks like Pythagorean theorem, right?
Yeah.
But it's not a right angle here.
Oh.
So we have to fix it. And the amount you fix it by is minus 2a times b times the cosine of gamma. And this generalizes the Pythagorean theorem. If the angle is 90 degrees, if that's a right angle, then C is the hypotenuse. What's the cosine of 90 degrees? Come on, people. Right? 0. Mark, what's the cosine of 90 degrees?
5.
Come on, Mark.
15.
What is the cosine of 90 degrees? Here's the circle. Here is 90 degrees. What is the cosine? The length is 1. It's probably easier to first say what's the cosine of this angle theta. Okay? Length is 1 and the coordinates are x and y. Okay? X, y. What's the cosine of theta?
1 over y. No, y over 1.
That's sine.
X over 1.
X over 1. Okay? All right, so about for this point, which is 90 degrees, what are the coordinates?
1, no, 0, 1.
Okay, so what's the cosine of 90 degrees?
1 over 0.
X over 1.
1 over 1. No, 0 over 1.
0 over 1, which is 0. Okay? So if this is 90 degrees, the cosine is 0. This piece goes away. We get Pythagorean theorem. Okay? Make sense? And so we want to prove this for any angles. All right? So, Luke, you're on. You're up here on this board. I'm going to draw you the same. No, we got a picture there. I'm going to tell you what to write on the next board. But look at the picture. We're going to drop a perpendicular from this point down to this angle. So that's a perpendicular. By the way, no one in geometry these days gets a name for that spot where the perpendicular hits.
D.
When I grew up in geometry, we called it the foot of the perpendicular. Think about it as a leg and the foot sticking out. There's the foot of the perpendicular. Okay? But nobody uses that term anymore, and they don't have a name for that thing.
It's the point at the end of the altitude.
Yeah, it's the point where the altitude hits the base.
Like this one.
And- yes. Okay, and now draw the other part.
One half.
No, it's not 1/2.
What happened here?
It's not 1/2. It doesn't split it evenly.
Oh, okay.
Okay? Draw the rest of the triangle. Okay? And that angle is beta. And A for that side. All right, let's name this height H. Okay? Write down the sine of alpha. Or what's the sine of alpha? You got a right triangle right here. What's the hypotenuse in that triangle?
This.
What letter?
E.
Okay, and which side is opposite? Which do we need for alpha? Opposite or adjacent?
The gamma.
Alpha.
Alpha. The opposite of alpha would be hypotenuse.
H.
H.
Not hypotenuse.
So it's E over H.
Is that right? You just did hypotenuse over opposite.
The opposite over hypotenuse.
Yes, opposite over hypotenuse. You have them backwards. Opposite. Yes, there is.
Okay.
Opposite over hypotenuse. Okay, now write down sine of beta.
So would this also be right angle?
Yes, if you take 180 and split it in half, they're each 90. Okay, now a little bit of algebra. Take this equation and solve it for h. H equals.
Wait,
Get the picture. Look at this equation. Just look at the equation. H is equal to, no, where are you getting an angle? An actual number. Just look at this equation.
Okay,
Sine alpha is h over b. Solve it for h. In terms of b and sine alpha. Let me give you a problem with actual numbers. 9 equals h over 4. How would you find h?
multiply 9 times 4. No, wait.
Yes? That's exactly right.
36.
So you would say h is 9 times 4, which is 36, right?
Yeah.
That's all I'm asking you to do, except instead of a 9, you write sine alpha. Instead of a 4, you write b.
H equals sine alpha b.
That's it. Equals h. We already have your h. Okay? All right. This is great. Back up so that people can see it. You're not quite done. This is fine. However, notationally, people can get confused whether or not you're multiplying b times the sine of alpha or b times alpha and then taking the sine. Yeah, that's really good. And even better, write the b first. And then there's no confusion about what you're writing. Okay? Solve this one for h.
Oh, right.
Excellent. Exactly right. Okay. Now write an equation that h equals h. This equals that. Write it up here.
Because there's a negative. It's flipped. It's flipped and then you multiply by negative 1.
Okay. Now divide both sides by a times b. Write ab then. Okay, and divide the other side also first before you start simplifying, so you don't forget. All right, now what do you say, Candace?
Cancel out.
Yes? And And on the other side, what can it do? Okay, now look at that formula and look at this formula. You just proved the law of sine.
Yes.
Did everybody follow the proof?
Yes.
Okay. Now Mark is on for the law of cosine. And
No, I want to write no.
No.
That's the point, dude.
all right, now this takes a few more variables in here. And it is not as easy as the sine one. So what we have to do is split up the angle gamma into two more pieces. And do you want me to use Greek or Latin? Latin. Okay. We're going to call this angle E, and this angle F, and this length P, and this length Q. They only go that much. Mark, what can you tell me about P plus Q?
Variable C.
Good. That's the first fact. C is equal to P plus Q. Okay, what can you tell me about the angles E and F? Mark?
They're equal to gamma.
Equal to each one? E is gamma and F is gamma?
No, add together they're equal to gamma.
Added together. Gamma is equal to E plus F. All right. And we are trying to compute this rule. The gamma there is E plus F. The C here is P plus Q. So we're going to start with gamma of cosine of gamma and work it out using what we know about these two pieces. So I think that's what I did. Yes. Okay, so I need you to write down cosine of gamma. Write high. You're taller than me. That's good. Cosine. Don't write so big because I'm not going to have space on the board. Medium size. This size writing is wonderful. Everybody can see. Cosine gamma equals cosine of E plus F. You need parentheses around the E plus F. Okay, now use the law of the cosine of a sum formula to split that up. Equals. You remember the law of cosine? The cosine formula of an sum of an angle formula. Okay, this is half of the trig route. The second half. Yeah, that's right. Cosine E. Okay, now we need to know the cosine of E. E is this angle, right?
Yes.
And we drop the perpendicular here. And so we have P, H, the height, and B, this side. This is alpha, so this is A. Okay? The sides are named opposite to their angle. Okay? So in terms of P, B, and H, what is the cosine of E? Everybody know the answer to my question? Mark's struggling with here? The cosine of E is equal to what over what?
H over B.
We have B, H, and P. What over what? That is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Jason. Okay, what is cosine of f? Bad notation. Cosine of f equals. Okay, what is the sine of e? The sine of f. You can see where we're going here. Okay. Sine of f. Opposite over hypotenuse. Which one's the Q? Your handwriting, I'm having trouble telling Q's from A's. Okay. All right. And now you need to take those four things and plug them in. Here, 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 and here. So equals. And go across. Cosine E is h over b times cosine f, h over a, minus sine of e, which is p over b, sine of f, which is q over a. Use the script A because you did the other place instead of your uniform. All right. So cosine of gamma is equal to that, right?
Wait, why? That's, no.
B is hypotenuse.
Yeah.
Okay? All right. I want you to take this equals this and multiply both sides by a times b. The reason is over here, cosine of gamma has to be multiplied by ab in the final formula. So you have a times b. Start with this side. A times b times this. Write it down. AB cosine gamma. A times b times cosine of gamma equals, and now what do you get when you multiply this by a times b? All right, now what you did is, no, don't start erasing it before you send it. What you did is multiply this by AB, that by AB, that by AB, and that by AB. That is not the correct way to multiply the whole right-hand side by AB. That's multiplying by AB, A squared, B squared. Okay? You only need to multiply by 1A and 1B. That's it. And get rid of one of them over there. Okay. Try again. That's something that when you take your algebra course, you'll get used to not over multiplying. Okay? All right, what cancels in here? Rather than erasing it, draw a line through the things that cancel. A cancels. Okay. Okay, so over here, what is it equal to? Okay, so we now have AB, cosine of gamma, is h squared minus p squared. All right, now we got a, I'm sorry, PQ, not p. Okay. Multiply through by 2, because that's what we're trying to build up, this formula. Multiply both sides by 2. You got to multiply this side by 2. Don't just put it there, because Got to recopy it. Because otherwise your equation is no longer true. Okay. Give me the pen for a second. I'm going to rewrite this. H squared minus 2pq plus h squared. Okay?
Where'd you get the, oh, I see.
I split up the h squared as two of them. Okay? I'm going to give it back to you. Equal sign. Here, next line, equals. That h squared, I want you to use Pythagorean theorem and give me h squared in terms of p and b. Look at this triangle, and what is h squared in terms of p squared and b squared? That would be true if h were the hypotenuse. It's not. Okay. And minus 2pq, just copy that down, plus h squared in terms of a and q. Okay. Good. Everybody agree? All right. Now, equals. Get the a squared and write it down. And put a little check mark over the a so you remember you used it. Okay, write down the b squared. It's got to be added in, plus b squared. Okay, and write down all the remaining terms. Minus c squared, minus 2pq, minus, what's left?
Minus u.
All right. We are almost there. Look back over here at our identity. We've got a 2ab cosine gamma. We've got an a squared, b squared. We're trying to get a c squared. Okay? So here is c. Write down c squared right here. C is p plus q. What is c squared?
2pq?
Write quantity, parentheses around p plus q. Square. All right, can you square that out? Pascal's triangle.
Oh, God. I forgot how he even did that.
Okay. It is p plus q times p plus q.
Oh, yeah.
Can you use the distributive law? Okay. Yeah. Just past the elevator. No. You get p times each of those plus q times each of those.
Oh, wait, no.
P squared plus nope. All right. Clearly you haven't had quite enough algebra yet. So let me work it out for you. Okay? Okay. This is equal to p plus q times p plus p plus q times q. It's this times this and this times this, right? Then the p can multiply each of those. P plus qp plus pq plus qq. Does that look good? Okay. And then that becomes p squared plus yes, they're the same. You can do two of them. Mhm. Yes. All right. So that is almost what appears here.
What with the subtraction?
Where's there a subtraction?
Right over there.
All of them have minuses. Okay? Multiply both sides of this equation by a minus. Minus c squared is equal to minus, minus, minus. And this is correct, but terrible notation. What is terrible about it is minus c squared is not equal to all the intermediate stuff. And that's why I would never, that's right. That's when I start writing it on a new line. Okay? So, minus c squared. So we come over here and replace all of this by minus c squared equals a squared. Whoa, why are you writing it on that side? This is what's on the left side.
At least they have.
That's what they make them.
But
See,
Right, copy down the a squared, copy down the b squared,
the best presents are the presents for you.
and plus sign. All of this, no, don't write it, because you're just writing the same thing. All of that is, look over here, Mark. All of that is minus c squared.
My mom made me.
So you could multiply it times -1.
Is that clear? Everybody got that?
You could turn everything into plus.
And now, okay, I will finish it up. Give me the pen, Mark, and go back to your seat. What Mark has found was 2ab cosine gamma is equal to a squared plus b squared minus c squared.
Wait, how'd you get that?
have you not been paying
From
attention?
here equals there.
Oh.
You've not been paying attention this
Okay.
whole time.
He has. He just lost track of where we got started. So this was equal to this, which 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 was equal to this, and I summarized it all there. Now we add c squared to both sides. C squared plus 2ab cosine gamma equals a squared plus b squared minus c squared plus c squared cancels off. Now we subtract this from both sides. C squared equals a squared plus b squared minus 2ab cosine gamma, and that is the law of cosine.
Whoa.
All right, so the rest of you, did you guys follow it? Because Mark hasn't had algebra, we were going a little bit slow. But that's okay, because you followed it. Okay? Any questions about it? Okay, we've done the law of sines and the law of cosines. That finishes all the identities. These two laws can be used to compute what are called evaluating or understanding a triangle. So if I give you a triangle and give you some of the sides and the angles, you can complete the computation of all the other sides and angles. So let me show you that, and when we go down to the computer, I will show you on the computer how to get to it. Suppose I give two sides of a triangle, say 5 and 7, and the angle between them is 30 degrees. What you have to find is this angle, alpha, this angle, beta, and this side, c. Okay, and then you will have solved the triangle. If you're given two sides and the angle between them, that is called a side angle side triangle. Side angle side triangle, and you can solve it. You can also do angle side angle, which would be a triangle where you know two angles, say 45 degrees, 30 degrees, and the side between them might be 9 units long.
You lost me off class.
You can immediately tell me what the third angle is, right?
Yeah.
What's the third angle?
It's like 105.
105. Okay? And the idea is to find the other two sides, A and B. Okay? So, how would you find A? One of those two laws will help you find A. The law of sines is the easy way to do it, because sine 30 over A is equal to sine 105 over 9. You can find A. Likewise, you can find B using law of sines. up here for this triangle, how am I going to find C?
Cosine, love.
Law of cosine. C squared is 5 squared plus 7 squared minus 2 times 5 times 7 times the cosine of 30. Okay? And that'll give me C squared, and I can get C. How am I then going to find beta?
Using law of sines.
Law of sines. Because sine beta over 7 is equal to sine 30 over C, which I already know. Okay? Likewise, and then how do I get alpha?
Sine.
Also
Law of sine.
Also law of sines, or 180 minus 30 minus beta. Okay, which is easier. Okay? So the law of sines and the law of cosines will allow you to, quote, solve a triangle if you're given side, angle, or angle, or side, side. 4, 7, 5. Okay? You should be able to find the other. So how would you find this angle? Law of cosines. Because you know 3 of the sides, you know the A, B, and C. From that you can find cosine of gamma. And so this is a 4, this is a 5, this is a 7, 5 and 7. I can find the angle gamma. Okay? And so I can find all 3 angles in a side. So there are applets that I have written which are for side, and angle, side, angle. And I don't have one for side, yet. If somebody wants to write one, I'll be happy to receive it. Okay? And your name will go up there, okay, as having written that one. I do have a start on that. Somebody started writing one for me. So that's solving triangles. So we have another 20 minutes, so let's start the next topic. Unfortunately, I do not have any kind of a handout on that, so you're going to have to take notes if you want notes. I have not typed up anything on complex or polar coordinates, which is next. Here is a circle. Here is the axes. Here is a radial line of length r, radius of the circle. The coordinates of this point are x and y. So the cosine of this angle theta is, everybody, whatever what?
X over R.
X over r. And the sine of theta is what? Y over r. Okay, x equals y equals. This is what I asked Luke to do before. When we did law of sines, how did you solve this equation for x?
Multiply r times cosine.
R cosine theta. R sine theta. Right? You did that before. You're the one who did that, right? Previously. The letters were different,
Yes.
but you did that before. If you tell me a point, I can find the distance of the point from the origin. So R is, what is the distance R to the origin given x and y? How do I find it?
It's the square root of
X squared plus y squared, take the square root. The square root of x squared plus y squared. So if I give you an angle and a distance out, I can find the x and y of the point. Given the point, I can find the radius. Can I also find the angle? How would you said yeah? How would you do that?
You know the point, right?
I got x and y.
Okay, well then the sine of the angle is y over r.
And you know r.
equals 1.
So you find y. Now that's fine. Now most people usually say the tangent
You're wrong.
of theta is equal to y over x.
Did you get that wrong?
And so turning that around, theta is,
It's not too late for.
have any of you learned about inverse trig functions? I'm about to say it.
Yes.
Turning this backwards is called arc tangent of y over x. So if I give you an angle, you can compute the tangent. Given the tangent of the angle, I can ask what angle is that for? And that's called the arc tangent of y over x will give you the angle. Okay? There is a small technicality. This point and this point here, diametrically opposed, which has coordinates minus x minus y, has the same y over x, and hence the same tangent. Okay? Benjamin, you had a question?
So that what you did with the tangent of theta to theta equals tangent, that's so it's basically you multiply each side by tangent.
No, it's not multiplying, it's doing it backwards. For example, if I say y equals x squared, then x is what? Square root of what?
Inverse.
So it's basically the marked on a calculator by the
Thing that's
thing
inverse.
negative one.
It has
Okay.
an inverse or a minus, possibly a minus 1. Okay? So this is a given function. This is undoing that function, going backwards. Likewise here, tangent is a function, arctangent is undoing the tangent function, just going backwards. That's frequently called the inverse function, and it's sometimes also denoted, I'll put 3 for identically equal, tangent inverse of y over x.
That should be done.
So you may see a minus 1 symbol on a calculator, or an arc, or an INV, inverse. Okay? And that means go backwards. So the inverse of the squaring function is the square root function. The inverse of the tangent function is this. There's a proviso here. When you do the square root, you always take the positive square root. There were actually 2 square roots. There are 2 square roots of 4, namely 2 and minus 2. But which one do you want? You want the plus 2. Likewise over here, if I tell you x and y, or this x and y, these 2 points, and I ask what angle gives it to you, the arctangent's going to give this one, not that one. So this formula with the arctangent is going to give the wrong one, just like square rooting always gives you the positive one. If you need the negative one, then you got to explicitly put the minus sign in. Here, the arctangent always gives an angle theta in quadrants 1 or 4. It always gives an angle here. Quadrant 1 or quadrant 4. The angle theta will always be between minus pi over 2 and pi over 2. Just like we always say, we take the positive square root here, even though there are 2 possibilities. Likewise on arctangents, there are 2 possible thetas which would give this answer, that angle and that angle. And by definition, the arctangent is always taking the one that's between minus pi over 2 and pi over 2. Okay? If you want it in the second or third quadrants, then you have to either add pi or subtract pi. So theta is arctan of y over x plus pi or minus pi. And let's see, if you're in quadrant 2, you add pi. In quadrant 3, you subtract pi. And that will give you the angles here and here, with the angles always between minus pi and plus pi. There are other ways of doing it. You can always do plus pi in 2 and 3. It's a matter of conventions. Maple uses, I think, plus pi everywhere, but I'm not positive. Different books use different conventions on how to get these other two quadrants. So, but normally, people usually say it's the arctangent y over x. It's technically only true for angles on the right half of the plane. Okay? Okay, that's much more complicated than I really intended to be. Okay? The point is, if you're given the point, you can find the r and the theta. If you're given the r and the theta, these formulas tell you the x and the y. Okay? So we call x and y the rectangular coordinates because the axes are perpendicular, and when you draw in the coordinate grid, you get rectangles. So rectangular coordinates are x and y. The polar coordinates are r and theta. If you know x and y, you can get r and theta. If you know r and theta, you can get x and y. And the only problem is, given x and y, when you get theta, you might be off by 2 pi, adding a multiple of 2 pi, because theta is not uniquely determined. You can go around or backwards to get to the same angle. And you have to be careful on theta between quadrants 1 and 4 versus quadrants 2 and 3. But you can always go back and forth. And so, just as we write down functions like this, y equals x squared, which is a rectangular equation, we can also write down something like r equals 1 plus cosine theta. And that is called a polar equation. You give me various thetas, I can find the corresponding r's. So I can make a chart, theta and r. When theta is 0, what's the cosine of 0?
90. 0.
0.
0.
No. What's the cosine of 0? 1. 1 plus 1 is
2.
2. Okay. When theta is pi over 2, or 90 degrees, what's the cosine of 90 degrees?
0.
How many vote for 0? How many vote for 1? It's just scratching your eyebrow, right? You're not voting. Okay, so 0 is correct. Okay, so we get 1. Then we go pi. What's the cosine of pi?
0.
No.
1.
No.
Negative one.
-1. So r is
0.
0. Okay, 3 pi over 2. What's the cosine of 3 pi over 2?
-2.
Cosines can't be outside -1 to 1. What's the cosine of 3 pi over 2?
1.
How many vote for 0? How many vote for 1? How many vote for -1? I don't see enough hands. I only saw 4 hands. What do you vote for? -1. No, pi was -1. 3 pi over 2. Okay, let's draw our circle. Okay? And cosine of theta is x over r. And the angle we're looking at is down here. What is x over r?
0 over 1.
0. So cosine of 3 pi over 2, 270 degrees, is 0, r is 1. So we can plot the curve. All right, now let's plot it. At angle 0, which is off in that direction, we have to go out to 2 in a distance. At the angle pi over 2, which is upward, we have to go 1 unit. When the angle is pi, which is off in that direction, we don't go anywhere. When the angle is 3 pi over 2, which is down, we have to go 1 unit down. Okay? 1 unit down, which actually takes us to the point y equals -1. Okay? We can fill in points in between. And so I do that with a graph. Now watch carefully. First I draw a rectangular graph of r and theta. So here is a graph, has theta on this angle, axis, and r on that axis. This is a rectangular graph of this equation,
Circle.
not a polar graph. Okay? Mark, if you want to understand this, you better pay attention, because this is not easy. If you turn your head, you're going to lose it. Okay, not your head, the concept. First I draw r equals cosine theta. It looks like that. Okay, starts at 1, goes down and up, and the period is at 2 pi. Okay? Then I have to add 1 to that. So this used to be minus 1 to 1, but now I have to add 1. So let's change colors so that it'll be there. R equals cosine of theta plus